Hi Olivarians! Welcome to the part 2 of Module 1, The Origin of the Universe and the Solar System. I am Miss Andrea S. Rivera from Dr. Pablo R. Olivares Senior High School Department at Olivares College, Parañaque, and I will be your instructor for NS001, Earth Science, and Earth and Life Science. Since you are here, I guess you are done with the first part of Module 1, which mainly deals or explains about the origin of the universe. Now, for the second part of Module 1, I will be discussing the origin of the solar system. Before we begin, I want you to think about for a minute on how the planets were formed. The universe may have begun with the Big Bang, which occurred 13.8 billion years ago. But it was only after 1 billion years that galaxies start to form. The age of the solar system and that of the Earth is approximately 4.54 billion years old. This is based on the age of meteorites, which are believed to have been formed the same time as the rest of the solar system. During the 16th century, there were models explaining the formation of the solar system. Do you know Ptolemy and Copernicus? Ptolemy and Copernicus are the first two proponents to formulate the early model of the universe, which are called the geocentric and heliocentric model. The geocentric model was formulated by Ptolemy, which described Earth as the center of the solar system. The moon, the planets, the sun, and the stars all rotate around the Earth, which stays still with uniform circular motion. It was generally accepted until the 16th century, after which it was superseded by the heliocentric model. The heliocentric model was proposed by Nicholas Copernicus in 1543, in which it states that the sun is the center of the solar system, which means Earth and the other bodies revolve around it. This diagram shows the comparison of the geocentric and heliocentric model. As you can see in the geocentric model, Earth is the center of the solar system, while in the heliocentric model, the sun is the center of the solar system. Just like the origin of the universe, there are many other theories explaining how the origin of the solar system began. Modern scientific concepts have provided new ways and new information in order to explain its origin. In this module, I will be discussing 4 scientific theories explaining the origin of the solar system. The first one is the Boffin's collision theory. Second, Jeffries tidal theory. Next, we have Kant-Laplace nebular theory. And lastly, we have the solar nebular theory. The first is the Boffin's collision theory. But what do you mean by collision? A collision is the event in which two or more bodies exert forces on each other in about a relatively short time. The Boffin's collision theory was developed by the French naturalist Georges-Louis Leclerc Comte de Buffon in the 18th century, who proposed that the planets were formed by the collision of the Sun with a giant comet. So the objects that collided with each other is the giant comet and the Sun. The resulting debris formed into planets that rotate in the same direction as they revolve around the Sun. Buffon claimed the entire cycle took more than 70 years to complete. Next is Jeffries tidal theory. This tidal theory was developed by Sir James Hopwood Jeans and Harold Jeffries in 1917. According to this theory, there are two separate processes that shape the Sun and the planets. This theory suggested that the sun and planets were formed from the substance that have been ripped out from the sun. So how do you think it happened? Well, they suggested that a star must have traveled past the sun where the tidal force or the gravitational pull side effect between the moving star and the sun pulled large quantities of matter out of the sun and the moving star. Some of the drawn out matter quickly cooled to become solid bodies called planetesimals. This theory is also backed up by old meteorites found on Earth, chemically dated back to about 4.5 billion years, the time approximated to be the formation of the solar system. Kant-Laplace Nebular Theory. This theory was developed by Immanuel Kant and Pierre-Simon Laplace in the 18th century. This nebular theory was the most accepted theory based on the consistency of its premises to current observations. The theory assumes that around 4.6 billion years ago, a great cloud of extremely hot gas and dust called nebula begins to collapse because of gravitational pull. The nebula started to spin rapidly when the gas cooled and shrank, forming a disc-like shape with a bulge in the center. The angular momentum from the rotation of the nebula and the gravitational force from the nebula mass form the outside gas rings. But what do we mean by angular momentum? Angular momentum is the quantity of rotation of a body, which is the product of its moment of inertia and its angular velocity. So as the nebula continued to spin rapidly, it cast off rings of gas that formed the planets and their satellites later on. So the gases clumped together, forming different sizes of planets and satellites. And the remaining part of the nebula, which had the most mass, formed the sun. That bulge in the center of the disc-like shaped nebula is the sun. And lastly, we have the solar nebular theory. The solar nebular theory is somewhat similar to the Kant-Laplace nebular theory. However, the main concern of this theory is to solve the original problems of nebular hypothesis of Kant and Laplace regarding the angular momentum of the sun. The solar system was formed as a result of the condensation of hydrogen gas and dust, referred to as the interstellar gas and dust cloud. The solar nebular theory suggested that something might have triggered the condensation of the gas and dust cloud, and this could have been a result of an explosion of a star, also known as supernova. The gas and dust collapsed due to the force of gravity, and the center compressed enough to become a young star, also known as protostar, leaving the outer material suspended around the center. So when the cloud begins to shrink, its rotational velocity increases to create a disc-like shape. The contraction transforms gravitational energy into heat energy that makes the center glow. And when the temperature is sufficient enough, a nuclear reaction begins at the core of the protostar and later becomes the sun. The rest of the material would form into the protoplanetary disk. According to the solar nebular theory, the formation of the planets involves different stages in contrast to the single process of Kant-Laplace nebular theory. The first stage is called the accretion, in which grain-sized particles form centimeter-sized particles which would later grow to several kilometers in diameter. The objects formed are called planetesimals. The second stage involves the formation of more massive objects from coalescing planetesimals. The massive objects are referred to as protoplanets. This would later on become the planets. So as the particles combined and clumped together, they became larger and larger, from grain-sized particles to planets. After the formation of the solar system, it was speculated that it produced a very powerful solar wind after 1 million years. Solar wind is a stream of charged particles released from the upper atmosphere of the Sun. So, as the protoplanet became sufficiently large, its gravity pulled the nebular gas, thus creating the gas giants. The protoplanets will either remain a rocky body or an icy body. After millions of years, the solar system finally ended up with the planets possessing stable orbits. And we can classify different planets based on their composition, their position relative to the Sun, and their position relative to the Earth. Under composition, we have terrestrial and gas planets. Under position relative to the Sun, we have inner and outer planets. And lastly, under position relative to the Earth, we have inferior and superior planets. Now let us define terrestrial planets. Terrestrial planets are classified based on their composition. They are made up of dense, rocky, and metallic materials that are found in their internal structure. The planets that are classified as terrestrial are Mercury, Venus, Earth, and Mars. Mercury, Venus, Earth, and Mars are also classified as the inner planets based from their position from the Sun, and these planets are significantly smaller compared with the other four planets. Next, we have the Jovian or gas planets. Jovian planets are composed of the primary materials that make up the Sun, which are helium and hydrogen. The planets that are classified as Jovian planets are Jupiter, Saturn, Uranus, and Neptune. These planets are also classified as the outer planets based from their position from the Sun. And these planets are significantly larger compared with the other four planets. Jupiter and Saturn are classified as gas giants also because they are larger than Uranus and Neptune. These giant gas planets are believed to have remained gaseous in nature because of their far distance from the Sun. The frost line, which divides the inner warm regions from the outer cooler region, allowed for the condensation of gas, forming a less dense, huge planet. After discussing the different classification of planets, let us now focus on planet Earth. Earth is the third planet from the Sun in the solar system, and scientists estimate that the planet is about 4.5 billion years old. As we study Earth, it becomes clear that our planet is a dynamic body with many separate but highly interactive parts, or as they call it, spheres. These are the atmosphere, hydrosphere, geosphere, and biosphere, also known as the Earth subsystem. These different spheres got their names from the Greek words that symbolizes what they are made of. Atmo is for air, hydro is for water, geo for ground or earth, and bio for life. Every sphere is in some way connected to the other. The parts of the Earth system are interconnected in such a way that a change in one part will bring about change in any or all of the other parts. These spheres interact with each other in order to achieve a common aim, and that is to sustain life on the planet. Most of the Earth's living processes depend on the light energy from its star, which is also known as the Sun. The Sun is considered to be the ultimate source of energy, since weather and climate, ocean circulation, and the process of erosion are driven by the energy from the Sun. Within Earth, energy also circulates to be made available and accessible to all life forms. The various forms of energy also require the recycling of the life-needed molecules and nutrients. The interstellar cloud of gas and dust that gave rise to Earth contained enough radioactive elements for billions of years to power a churning core. The churning core of the Earth creates a magnetic field that protects the planet from dangers like solar winds or solar flares. Solar flares are large eruptions of electromagnetic radiation from the Sun. Aside from the energy that we get from the Sun, the Earth's position in the solar system is situated in the so-called habitable zone, or also known as the Goldilocks zone. The habitable zone is the region around a star where the surface of surrounding planets is not too hot and not too cold for liquid water to occur. The distance of the Earth from the Sun is just right for water to remain liquid. Other planets are not in the habitable zone because they are either too close or too far from the Sun to harbor liquid water. And life as we know it requires liquid water. That is why water is another factor that can sustain life on Earth. Water, in its liquid form, is vital for DNA and proteins. They interact with the environment to carry out reactions needed for life. Most of the Earth's water is contained in the oceans, comprising over 96% of the total hydrosphere. Glaciers, ice caps, and liquid fresh water share the remaining 4%. Another factor is the Earth's moon. Earth has one moon revolving 29.5 Earth days around it. As the moon revolves, it is possible to observe its different phases in the night sky. It also helps to stabilize the Earth's position. The moon is associated to high and low tides. Tides cause changes in the depth of the sea and also produce oscillating currents known as tidal streams. And lastly, another factor that can sustain life on Earth is the Earth's atmosphere. Earth is also surrounded by a life-giving gaseous envelope called the atmosphere. This thin blanket of air is an integral part of the planet. Aside from the Earth's magnetic field, the planet also has another protective layer called the ozone layer, which blocks and protects us from the sun's intense heat and dangerous radiation. And that's it, class! Now you know the origin of the universe and the solar system. Thank you so much for listening and watching with me. Remember to stay at home and keep safe. Once again, I'm Miss Andrea S. Rivera, your instructor for NS001.
Happy learning at home with lessons made easy by Olivarian GoTeach. One proud Olivarians.